In math, we are going to be mentally adding and subtracting 10 and 100. And when we think of mentally, we think being able to do something in our heads. Mentally adding and subtracting 10 and 100. Plus 10, minus 10, plus 100, minus 100. Adding and subtracting these numbers. Let's try to solve a problem together. What is 120 plus 10? So what is 120 plus 10? 120 plus 10, that equals 130. And I want to talk about a couple different ways that we could find that answer. There's a lot of different resources that we could use. We could start at 120 and count up one number until we get to 130. We could find 120 on a chart and look one number below it, knowing that when we go down a hundreds chart, the number gets bigger by 110. We could look at 120, but ignore the 100 and think 20 plus 10, that's 30. And then add back in the 100 to get 130. We could think about counting by tens. 100, 110, 120, 130. 10 more than 120 is 130. So the answer is 130. There's a lot of different strategies that you could use to figure out 120 plus 10. But when it comes down to it, 130 is 10 more than 120. Which strategy do you like best? Do you like going down one because you know it's just faster? Because you know it's just 110 more? When you add numbers in your head, it's called mental addition. When you subtract numbers in your head, it's called mental subtraction. Today, we're going to try to use some patterns to help us find rules for adding and subtracting 10 and 100 mentally. Let's start with this number, 221. 221. And we are going to skip count by tens. Ready? Do it with me. 221, 231, 241, 251, 261, 271, 281. I'm going to stop there. What patterns do you notice? How about the ones digit is always 1? There's always a 1 in the ones place. What else do you notice? What other patterns do you notice? How about the tens digit goes up 1 in each time that we count? 2, 3, 4, 5, 6, 7, 8. The tens place got bigger by 1 10 every time that we went up a count. What else do you notice? How about the hundreds digit is always 2? 200, 200, 200, 200, 200, 200, 200. Let's count some more. We're at 281, 291, 301, 311, 321, 331. I'm going to stop there for a minute. What do you notice about the hundreds digit? It stayed the same, 200, until the tens digit is 9. When you count up by one more 10, the hundreds digit goes up by 1. And the tens digit goes to 0. So, the hundreds digit stays the same until the tens digit is 9. When you count up by one more 10, the tens digit goes to 0, and the hundreds digit goes up by 1. That's because when you have 9 tens, (10, 20, 30, 40, 50, 60, 70, 80, 90), and you add one more 10, you get 10 tens, or 100. And that's like trading base 10 blocks. So then you'd really have a flat. And then we keep going. 311, 321, 331. I have a new number written out. 547. 547. This time we're going to count back by tens from 547. Ready? 547, 537, 527, 517, 507, 497, 487, 477. What patterns do you notice? How about the ones digit stays the same? 7, 7, 7, 7, 7, 7, 7, 7. And how about the tens digit? This time, since we're counting backwards, the tens digit goes down 1 at each count. 4, 3, 2, 1, 0, no tens. 9, 8, 7. And the hundreds digit stays the same. 5, 5, 5, 5, 5. Until the hundreds digit stays the same until the tens digit is 0. When I count back by one more 10, the hundreds digit goes down by 1, and the tens digit goes to 9. So, how is counting by tens similar to adding or subtracting by tens? Adding 10 is like counting up 10. Subtracting 10 is like counting back 10. How could we use these patterns to think of a rule for mentally adding or subtracting 10? Let's check it out. When you add 10, the tens digit or tens place, it goes up 1. And the other digits stay the same, unless you have to make a new hundred. When you subtract 10, the tens digit goes down 1, and the other digits stay the same, unless you have to trade 100 to get more tens.